Hi, greeting to everyone. My name is Muhammad SYAUQI bin ASRI. I come from Group F. So today, me and my friend, we are going to present about this topic, application of differentiation, which we are going to focus on related rate problem. Okay, so here are my fellow mates. We have Amirul AIMAN bin RIDZUAN as the group leader. Next, we have Muhammad FIRDAUS bin HAFIZ as a group thinker. And last one, Muhammad SYAUQI bin ASRI, me, as the group editor. So, in this presentation, we have 5 content. The first content is introduction of the topic, which the topic is application of differentiation. The first content will be presented by me. Next, we have problem statement that will be presented by FIRDAUS. The third and the fourth one, problem solution and the conclusion, will be presented by Amirul AIMAN, the group leader. And the last content is reference. So let's proceed to the next content. So what is differentiation? From my research, the differentiation is a method or a process that we can measure the rates of change of some quantity with respect to another quantities in a function. This rate we get from differentiation will also call as derivative. So if you want to know that the fact is rate of change is same as gradient in a graph. So for example here, in this graph, we can find the rate of change if we know the gradient. So if we want to calculate the gradient, we will use this formula. Delta y divided by delta x. So if we use this formula, we can find the gradient, which means we can find the rate of change from the graph. For example, rate change of displacement with respect to time will call as velocity. So why we use it? Why we use differentiation? So crystal clear that we use differentiation to allow us to find rate of change. In real life, we use this method, this process to help us in our life. For example, here have 3 examples. The first one is to calculate the profit and loss in business in graph. So you know that we can find the rate of change by know the gradient in a graph. So yeah, it's true. Next, to check the temperature variation. The third one is to determine the speed or distance covered, which for example, meter per second, kilometer per hour. So next, I will pass this slide to Firdaus. Firdaus will continue.
Hello, Assalamualaikum and good morning to everyone. My name is Muhammad Firdaus bin Najib Hafiz. My metric number is 2021 479 456. So today I want to present about identify the problem statement. So the question state that a 6-feet man walks at a rate of 3 feet per second away from a street light that is 21 feet above the ground. Question A. At what rate is the length of his shadow changing when he is 8 feet from the light? Question B. At what rate is the tip of his shadow moving when he is 10 feet from the light? Objective of the question. So, in this question, we want to What things to solve? Main objective and creative thinking. What things to solve? The speed of the shadow changing when the man is 8 feet and 10 feet from the light. Main objective, better understanding about differentiation, change problems involving geometry formula. Creative thinking, be able to apply the chain rule method or implicit method to solve the question. Thank you.
Hello, my name is AIMAN bin RIDZUAN. My matrix number is 2021455306. I will be showing you guys the problem solution. So let's go to the next slide. Okay, so the question asks that what rate is the length of the shadow changing when he is 8 feet from the light? As we can see, there are two triangles shown. On the large one represent the height of the street light, which is 21 feet. X is the distance between the man and the street light, while S is the length of the shadow that performs behind the person from the light. L is the sum of the X and the S. On the smaller one, represent the height of the man, which is 6 feet tall, and S is the length of the shadow. You notice that these two triangles have the same angle theta, so we can apply the trigonometric formula, which is SYAUQI. The one that we can use is tangent. So tangent opposite adjacent. So on the larger one, tangent theta equal to 21 over x plus s. On the smaller triangle, tangent theta equal to 6 over s. As we know that both theta are equal, you can just put it together. 21 over x plus s equal to 6 over s. Next is, from the same equation, we can just cross multiply it. 21 times with s and 6 times with x plus s. The answer will be 21s equal to 6x plus s. 6x plus s, we can multiply it. It will become 6x plus 6s. 21s and 6x, we can subtract it. The final answer will be 15s equal to 6s. Once we get to this part of the equation, we can perform the implicit differentiation. It is to find the derivative of both sides of the equation with respect to time. It will be 15 ds over dt equal to 6 ds x over dt. From the statement, a man walked 3 feet away from the street light. So that means dx over dt equal to 3 feet over 3 feet per s, 3 feet per second. So we can just put it in the equation. So it will be 15 ds over dt equal to 6 times with 3. 6 times 3 equal to 18. 15, we brought it to the right side. It will become 18 over 15. The final answer will be ds over dt equal to 1.2 feet per second. This is the rate which of the shadow changing every second. So let's move on to the next questions. Next question is, what is the rate of the tip shadow when he is 10 feet from the light? It means we need to find the dl over dt. Let's start with the equation 21 over x plus s equal to 6 over s. As you know that x sums s equal to l, so we can just substitute it into it. 21 over l equal to 6 over s. From this equation, we can cross multiply it. 21 multiply with S and 6 multiply L equal to 21. The final answer will be 21S equal to 6L. Once we get this part 2 of the equation, we can perform the implicit of differentiation. We need to find the derivative of both sides of equation with respect to time. The answer will be 21 ds over dt equal to 6 dl over dt. As we know that we already got the ds over dt from the previous questions. ds over dt equal to 1.2 feet per second. We can just substitute it into the equation. So 21 times with 1.2 equal to 6 dl over dt. From this point, we can get the dl over dt. We will get 6 dl over dt equal to 25.2. So dl over dt equal to 25.2 over 6. The answer will be 21 over 5 or 4.2 feet per second. So that is the rate of tip shadow when he is 8 feet, when he is 10 feet from the light. So let's go to the conclusion. The application of differentiation is used to compute the rate of change using trigonometric formula. So it turns out that as long as the man is moving at a constant rate, the rate of his shadow will also remain constant at 1.2 feet per second, regardless of how far away he is from the street light. Okay, thank you. That's all from me.